Moving on to the next question in the series of GATE 2024 easy solutions from subject Engineering Mathematics. Question was 55 in the master question for GATE 2024 easy. The 2 marks MSQ or multiple select question having more than one correct answers. Question 55 from the master official question for GATE 2024 easy from subject Engineering Mathematics is as follows. 2 marks MSQ. It is from basically eigenvectors, eigenvalues and eigenvectors. So it is given, consider the matrix 1k to 1. 1k to 1. Where k is a positive real number. Okay. The question is, which of the following vectors is or are, as it can be one or more than one correct, eigenvectors of this matrix. The options are given as, options are 1 minus of root 2 by k, option B 1 root 2 by k, option C root 2k 1, and option D root 2k minus 1. Let's move on to solution of this question. It is a simple question based on eigenvectors and eigenvalues. Solution to आगे बढ़ते हैं. Okay. Let the given matrix be taken as A. So let A equal to 1k. Now what we have to find? Let's find out the eigenvalues of A. How will we find out? Very simple. Characteristic values or eigenvalues are given there is equal to lambda times I, where I is in identity of unit matrix, minus here order of I is 2 into 2, as A is of the order 2 into 2. So lambda I minus A equal to determinant of lambda minus A is 0. So lambda by lambda is the eigenvalues. What we get? Lambda I is nothing but lambda times 1 0 0 1. That is lambda 0 0 lambda. So this will be what? Lambda minus 1, 0 minus k, that is minus k, 0 minus 2 is minus 2, and lambda minus 1. So determinant of this is 0. So if we simplify this or evaluate this, we get lambda minus 1 whole square, minus 1 times lambda minus 1, minus 2 into minus k equal to 0. So lambda square minus 2 lambda plus 1 minus 2, 3 minuses are there, so the net will be minus. So minus 2k equal to 0. Right. So what are the characteristics of eigenvalues? Lambda minus 1 whole square minus equal to 2k. Take this term over here. So we plus minus square root of 2k. So lambda would be what? 1 plus minus square root of 2k. So this is the eigenvalues basically. Eigenvalues of A, given matrix, square matrix. So eigenvalues of A. Corresponding to both of the eigenvalues, we will have two distinct eigenvectors. Right. One of the eigenvalues is say lambda 1 time equal to 1 plus 2k. Another one will be lambda 2 time equal to 1 minus 2k. Corresponding to each of these eigenvalues, हर एक दोनों में से दोनों eigenvalue के लिए दोनों अलग-अलग eigenvector मिलेगा, जो कि हम लोग को निकालना है. That we have to find. Okay. Now we can go for the usual approach, but easier approach is what? If we go by the options, right? Right. So if we multiply these, the given matrix with the eigenvectors given in the options, we can do it easily. Let's do one by one. So if we multiply this vector with 1 minus of root 2k, it is this matrix, this eigenvector. In fact, what we get? 1 k into minus root of 2k is what? Minus root of 2k. Right. Here we have to get 2 minus root of 2k. If we take 1 minus root 2k common, what do we get? 1 here. Right. We get 1 here, right? A into this matrix eigenvector, okay, 1 minus of root 2k, 2 minus of 2 root of 2 by k. Okay. So here if we take minus of root of 2 by k, we multiply this term, we get this term. You observe carefully. 1 times minus root of 2 by k is minus root of 2 by k, and minus root 2k into minus root 2 by k gives what? This minus minus will cancel and k is cancelled, and root 2 with 2. So basically, if you take 1 minus root 2k common in this term, we get this. You can check. Right? So basically what you are getting? You are getting in this form. Ax equal to lambda, Ax equal to lambda times x. So this is the eigenvector, corresponding to the eigenvalue, this one, which is lambda 2. Or 1 minus root 2k. Corresponding to this eigenvalue, the eigenvector is this. for the matrix 1k to 1 as is shown. Ax equal to lambda x. This is the x or eigen vector, and lambda is 1 minus root 2k in this case, which is lambda 2, second eigen. So 1 and minus root 2 by k is one of the eigenvectors. Surely we'll have another eigenvector. By symmetry, what we can say, or by some logic, what we can say, if this one is minus of root 2 by k for the eigenvalue 1 minus root of 2k. So the other eigenvector will be what? For the eigenvalue 1 plus root 2k, this will be, there will be plus sign instead of minus here. प्लस साइन होगा, मतलब दूसरा आइगन वेक्टर क्या हो जाएगा 1 और रूट 2 के, ठीक है। तो एक्चुअली ये होना चाहिए b होना चाहिए, उस हिसाब से देखेंगे तो लेट्स वेरीफाई इट, इट्स b or not. So let's write it here, take this space. A is what? 1k 2 1, and this eigenvector let's write down 1 of 1 and root of 2 by k. Okay, so it will be 1 into 1 1, k into 2 by root k, so root of 2 by k, so it will be what? Root 2k, 1 plus root 2k. Here it will be what? 2 plus root of 2 by k. We take 1 plus root 2 k common. What we are left with? 1 here, and here what will we get? Root of 2 by k. If we multiply root of 2 by k with root 2k, what will we get? 2. And if we multiply root of 2 by k with 1, we will get root of 2 by k. So it will be basically this. So again, let's say this earlier one is x2 lambda 2. Now what we get? A into x1 equal to lambda 1 into x1. Lambda 1 is 1 plus root of 2k. x1 is 1 root of 2 by k. So A into x1 equal to lambda 1 into x1, which is of the form ax equal to lambda x, corresponding to eigen values lambda 1, eigen value lambda 1. x1 is the eigenvector. So the eigenvalue corresponding to eigenvector corresponding to lambda 1 equal to 1 plus root of 2 is 1 root of 2 by k, which is option B. As there are only two eigenvalues, there will be only two eigenvectors, which you already found here. 1 minus root of 2 by k, 1 root of 2 by k. So the correct eigenvectors are the ones given option A and B. And the correct answers to this question, multiple select question, are options A and B. I explained the steps on the very basics of eigenvalues and eigenvectors, and we derived the answers, eigenvectors, to both the eigenvalues of the given matrix. Hope the solution is clear. If you have any doubts or queries, please for the solution of this pretty simple question, please feel free to ask in the comments. And that's all for the question. That's all for this question. Solution to the question. Also for the subject engineering mathematics, the question that came from Gate 22 AC. I have provided solutions to all the 10 questions. If you have any disciplinary doubts or queries, any of the questions, please feel free to ask in the respective comments. And I will be glad to answer and resolve your doubts. So thanks for watching till the very end. That's all for this question. That's all for this video. Thank you.